Okay, guys, we're going to talk about Chapter 2, Part 3, which is the remainder and the factor theorems. So these are related to polynomial division. Polynomial division. So we're going to divide polynomials using two methods, long division and synthetic division. And then we're going to apply the remainder and the factor theorems. So here are some definitions. First of all, the synthetic division technique is sort of a shortcut method for dividing any polynomial by a linear divisor. So the key here, you see the divisor is x minus r. The divisor must be linear for synthetic division to work. It must have degree 1. In other words, 1 being the highest power of x for the denominator. That's to use synthetic division. A depressed polynomial is when you reduce the degree of a quotient after you divide. So you have an initial degree in the numerator. After you divide it by a polynomial, the resulting quotient will have a reduced degree. And it's sort of just the quotient part, or sorry, the polynomial part of the quotient. And synthetic substitution is a way to use synthetic division to evaluate a polynomial. It's a really quick and neat way. You'll be fascinated by how quickly you can evaluate a polynomial using this method. You know, where you plug in a value for x and figure out what the polynomial's y value would be at that x. You can do it at extremely rapid speed here. Okay. So long division to factor a polynomial. So we're going to factor this completely, 6x cubed plus 17x squared minus 104x plus 60, assuming that 2x minus 5 is a factor. So before you can begin to factor a complex polynomial like this, you need to have something to divide into it. So here we're given one. Later on, we'll have to find it ourselves. But you remember this from second grade, right? You put the divisor outside the house, and then the dividend inside the house. And then the quotient will be up here. The remainder will be down here when we're finished. So this process works using the old division algorithm, DMSB, which you may have learned in second grade. Divide, multiply, subtract, bring down. You remember this? Happier times, wasn't it? Divide, multiply, subtract, bring down. One way to remember that is, does McDonald's sell burgers? Why, yes, they do. So the way we're going to divide is exclusively using the leading term of the divisor, and then we're going to divide that into each of these terms. So we use the leading term of the divisor, and then every term of the dividend. One at a time, though. So the first order of business is to divide this into the next term of the dividend. In this case, we haven't started yet, so it's the first term. So how many times will 2x go into 6x cubed? I can write that here. You guys see how that's 3x squared? So 3x squared goes up here. That's the divide part. Then we multiply. 3x squared times 2x, 6x cubed. And then 3x squared times -5. Now here's a mental note to make. People screw this up quite often. When you multiply, you must multiply by both terms. So also the -5. 3x squared times -5 is -15x squared. So there's the multiply. Now let's subtract. So I'm subtracting both of these values from the corresponding values in the dividend. 6x cubed minus 6x cubed is 0. You should always get a leading 0 if you're doing this properly, until the very end, in which case what's left over will be the remainder. Now, 17x squared minus a negative 15x squared is 17x squared plus 15x squared, which is positive 32x squared. Questions about that? So that's the subtract part. And now the very last part, I bring down the next term. So there is the first application of the division algorithm. And we'll do that over and over again until we get to the point where we can no longer divide. So going again here, divide. This time we're going to take 2x and divide it into 32x squared. So whatever the next greatest term is. So 2x will go into 32x squared 16x times. Now we multiply. 16 times 2x is 32x squared. And then 16x times -5 is minus 80x. So there's the divide and the multiply. Now we're going to subtract. So we get a 0 here, as we expected. Negative 104x minus a negative 80x is negative 104x plus 80x. So the result here is negative 24x. And then we're going to bring down that last value. One more time. So now we're going to do 2x into 24x. So 24x divided by 2x equals 12. Everybody see that? Stop me if you're not sure where a number came from. And then 12 times 2x, I'm sorry, that's negative 24x, so that should be a negative 12. Not bad. Forget the signs matter. So negative 12 times 2x is negative 24x. There we go. I knew those had to be the same. And then negative 12 times -5 is plus 60. So when I subtract here, so I've divided, I've multiplied. When I subtract here, I'm going to get 0 plus 0. There's nothing left to bring down, so we're finished with this problem. And this is the quotient. But they want us to factor it completely. So I need to shrink down all this stuff. Try to leave it legible there. So look, they take this original polynomial, and we'll say that equals 2x minus 5 times this quotient. So saying that this divided by this equals this, is the same thing as saying that original polynomial, which is the dividend here, are the divisor times that quotient. So 42 divided by 2, what's the answer? 21. So what's 21 times 2? So you see how this is just saying the same thing. So I've rewritten it as the product of the divisor and the quotient. Now I can try to factor this quotient. This is a pretty complicated factoring because the a value is not equal to 1. And you haven't seen me do one like this yet. So pay attention here. I'm going to factor this quadratic if possible. If it's not factorable, we'll just state that it's an irreducible quadratic and this is completely factored as is, although I suspect it will factor. Okay, so the first thing you need to do is you find your n and n to rewrite that center term. And I need them to follow 2 rules. First of all, they need to have a product of a times c. So that's 3 times negative 12. I need them to multiply together to make negative 36. And I need them to add together to correspond to that b value. Ax squared plus bx plus c is where I'm getting a, b, and c from. So I need them to add together to be 16. So 2 things that add together to make 16, multiply together to make negative 36. I see what they are. It's kind of tricky. 18 and negative 2. So 18 and negative 2 add up to this and multiply together to make this. If you don't have a good intuition for that, there's all sorts of online calculators and stuff that can help you. But also, you could list all the factors of 36 and look for ones that have a difference of 2 or add together to make 16. Yeah, okay. So I'm going to shrink this bit because it's kind of in the way. So I'm going to rewrite this as 2x minus 5. He's still hanging out here. But this middle term, I'm going to make 3x squared plus 18x plus a negative 2x minus 12. So I use those 2 numbers to rewrite that center term. And notice my plus a negative here. If your third term is negative, write it as plus a negative. Otherwise, when you do this next step, it's really easy to make a sign error. So what I've done now is I have grouped the first 2 terms and the second 2 terms. Now I can factor out GCF from each. 2x minus 5 is still hanging out here. So with this first one, 3x squared plus 18x, 3x is my greatest common factor, which leaves me with x plus 6. And then negative 2 is my greatest factor over here, which leaves me with x plus 6. And if you do this right, ladies and gentlemen, your binomials should be the same here, the ones inside the parentheses. Because now on this next step, I can factor out that binomial and get the following. Sure my equal signs make sense here. Well, don't need one there because I've got it there. Okay, so fully factored. Yeah, that's the... They didn't ask us to list the zeros or anything. So we fully factored that very complicated polynomial using a known 0. So we knew where 0 was. They gave us this factor. So we divide this into it, get that quotient, factor that quotient, and get a resulting list of 3 factors. Don't forget to include the original factor. Questions about any of that? All right, that, ladies and gentlemen, is long division. So this is your book's little page on polynomial division. So it tells you that the quotient plus the remainder over the divisor. This part you need to note. Computer, enlarge. Thank you. You didn't know it's voice activated, did you? The reason why that's important is because it includes a description of what to do with the remainder. On that last problem, we didn't have a remainder, so we didn't have to worry about it. On subsequent problems, we may. But notice you place it over the original divisor and add it at the end. Okay, let's move on here. So, non-zero remainder, that's kind of a hint about what's going to go on here. But I'm going to write this, and you guys help me set it up. So here's our little house. Caitlin, tell me what goes outside the house here.
2x minus 1.
Excellent. Allie, what about inside? That's okay.
6x minus 5x squared plus 6.
Excellent. So does McDonald's sell burgers? Well, in case you're a health nut, let me enlighten you. Yes, they do. And cheap ones. Isn't it really interesting that a cheeseburger, a double cheeseburger, $1.49 or whatever, but a salad is like $6? What does that say about America? Well,
that's why obesity is one of our biggest problems.
it is. You're right.
If you go anywhere in the world, it's the exact opposite. The cheeseburger is like $6 and the salad is $1.
Exactly. And if you talked about, the cost of manufacture, McDonald's pays surely 2 or 3 times as much for that cheeseburger as they do for the salad. So why do they have that inverted price scale? Doesn't make any sense unless they're trying to hook you. Like, crack at, hey kids, you want to fly?
Yeah, you get addicted to the other stuff.
But anyway, does McDonald's sell burgers? Yes. Colby, what goes right here?
$3x².
Excellent. Coincidentally,
The
the same as the previous problem. That's just a coincidence. And then tell me, Caitlin, what goes right here? We're on the multiply part now.
You would multiply 2x and 3x squared, so that's 6x cubed minus, and then you would multiply -1 times 3x squared. So that's -3x squared, and then you minus that.
Excellent.
Or subtract that, sorry.
Excellent. Yeah, don't forget the subtraction should go outside because it's easy to make a sign error. Macy, what goes right here?
-2x squared, or 0 plus -2x squared. Sorry.
Excellent, excellent. Well, be careful, it should be -2x squared.
Yes.
So, and the reason why is -5x squared minus a -3x squared is -5x squared plus 3x squared. And so we get -2x squared. And then, Riley, what do I do next? This bring down part.
Bring down 9.
Excellent. Okay, let's see. Clay, what do I do next here?
You would divide 2x minus 1 into 9x and plus 6.
So you're close. This goes into the
Into
the -2x squared.
That's not the greater number, it's just the number next to 0.
The one that has the highest power of x.
Okay.
So not the greatest coefficient, the one that has the highest power of x. Good question. All right, so what would the result be that I write here in the quotient? Let me give you a hint. I'm sorry, buddy.
So it would be just x, negative x.
Very good. So now we multiply, and let's see. Who have I not called on recently? Mackenzie. What goes right here?
Negative 2x, and then plus x.
So I agree with the plus x, but you see how this is 2 powers of x here?
Yeah, oh, yeah,
So I
sorry,
should-
I forgot to say.
That's okay. It's okay. We have to be very meticulous, very detail-oriented with these problems, because you see how any kind of little bitty error, and you get all the way to the end of the problem, you just spent 20 minutes on this freaking problem, and you get to the end, and you know something's wrong because the answer's weird. So don't put yourself in that difficult spot. And even though this minus sign is out here, we still have to subtract the whole thing. So that's going to be 0, and then tell me what goes here, Colby.
8x.
Good. And so now, last time, we're going to bring down 2x goes into 8x plus 4 times. 4 times 2x is 8x. 4 times minus 1 is minus 4. So this is going to be 0 plus 10. So we do have a remainder. We've got a quotient. So that's q of x. Let me make this a little smaller. There we go. So we've got a q of x, and we've got an r of x. Even though there's no x involved, we can still call it that if we like. So the question is 6x cubed minus 5x squared plus 9x plus 6 divided by 2x minus 1. So that's going to equal the quotient 3x squared minus x plus 4 plus the remainder over the original divisor. So the new part for this problem is that remainder divisor business. Okay, any questions about this one? Or thoughts or comments? Yes, ma'am.
Would you be able to factor this down anymore?
Well, no, because of this remainder.
All right, so
So-
those are just not factorable.
Always a non-factorable result when you have a remainder.
Okay.
Very good question.
So we just leave it.
Yeah, this is the final answer. Very good question, Caitlin. If you encounter a remainder, then the divisor you started with wasn't even a factor. Yes, ma'am.
On the last problem, whenever we go like put in our answer or whatever on our homework, whenever we get like the quotient with no remainder, do we just put the quotient or do we need to plug it into the whole problem?
And factor?
Yeah,
That would depend on the question. In some cases, yes. In some cases, no.
because now like on the last one, we can do like the 6x to the third power.
Yeah, the reason why that was the case is, you see how the task was to factor completely.
Yeah, I just didn't know if it was the, not like the factor completely, but the one we did before that, where it's just like the problem and then equals 2x minus 5, and then you plug in the quotient, and then just leave it. I don't know if we need to answer it that way. Or just
I prefer this way.
Okay.
Yeah, the book has a couple different ways they present it, like this, for example. I prefer this way, which is what you see here.
Okay.
So the quotient plus the remainder over the divisor. Good question. Any other questions? All right. So what if we're dividing by something that is degree 2. Well, that can create a more complicated problem, but interestingly, it generally makes them shorter. I'll show you one. So leading terms, x squared into x cubed goes x times. That's the divide part. Now the multiply part. You see how we're going to knock out, potentially several terms at once. It's not going to happen this time. It could be the case that you have only a couple steps here. So x cubed minus x cubed is 0. Negative x squared minus a negative 5x squared is negative x squared plus 5x squared, which results in plus 4x squared. Negative 14x minus 6x is negative 20x, and then you bring down the plus 4. So x squared into 4x squared is plus 4. So that's 4x squared. 4 times minus 5 is minus 20x. 4 times minus 5x is minus 20x. And then 4 times 6 is plus 24. We'll subtract all that away. So that's 0 plus 0 minus 20. So quotient, remainder. Don't forget that minus sign is part of the remainder. So I would say x cubed minus x squared minus 14x plus 4 divided by x squared minus 5x plus 6 equals x plus 4 plus negative 20 over x squared minus 5x plus 6. Quotient plus remainder over divisor. Any questions about this one? Thoughts or comments? Okay. A lot of calculation here, a lot of potential for an arithmetic error. I'm doing a lot of this arithmetic mentally, but you should know your own strengths and weaknesses. If mental arithmetic is a weakness, there's nothing wrong with that. Everybody's different. Make sure you use a calculator as you go. And you would know that because, the first couple problems, maybe you make a mistake somewhere, and you'll know that probably it's a better idea for you to use a calculator as you go. All right, so the synthetic division algorithm. This is best demonstrated in an example, but know that your book has this detailed plan here. I'm going to demonstrate it exclusively by working the problem because it's been my experience that that's the best way to do it. But know that your book has this description of the synthetic division algorithm in it. Okay, so we're going to use synthetic division. And the first thing we should always do is ask ourselves if synthetic division is appropriate. So is the divisor linear? In other words, is x to the first power the highest power of x? Yes. And so synthetic division is appropriate. Now, given that it's appropriate, we need to do our little setup. So first of all, we're going to take whatever x is modified by here and change the sign and put it here. X minus 3 becomes positive 3 as your special number. So we got minus 3 here. We put a positive 3 here. Now we're going to list the coefficients in the dividend in descending order of power of x. So we start with the highest power of x, and then the next highest, and the next highest, and so on. And in this case, our job was made pretty easy by the fact that it was in standard form. In other words, it went from highest to lowest, from left to right. So that task wasn't difficult. But if these had been jumbled up, you see how it might have been a challenge to arrange them like so. All right, now we're going to do this. So this is our setup. You take the number that modifies x in the divisor, put it here. And then you put a list of the coefficients in the dividend, starting with the highest power of x and ending with the least power of x. And then you draw a line here. So this is going to be a little table method. Mason?
So if that was x plus 3, would it be a negative 3 right
Yes.
box?
Mm-hmm. Good question. The question was, if this were x plus 3, would this be a negative 3? And the answer is yes. Okay, so the first thing we do is bring down that first value into that lower table. So 2 just comes straight down. Now, starting with 2, when we go across, we're going to multiply by our special number. So 2 times 3 is 6. And then we add downward. So negative 4 plus 6 is 2 again. And as we go up here, we're multiplying by 3. So we get 6 again. Whatever this special number is, that's what we multiply by. Negative 3 plus 6 is 3. And then we multiply by 3 again. 3 times 3 is 9. Negative 6 plus 9 is 3. 3 times 3 again is 9. Negative 5 plus 9 is 4. 4 times 3 is 12. Negative 8 plus 12 is 4. So once you have this bottom row, you have your answers. Everything but the last value are going to be your coefficients of your quotient polynomial. And then your last value will be the remainder. So I'm ready to write my answer now. And I caution you not to fall in love with this, because it's going to seem so much more efficient than what we did before. But remember that it only applies when you have a linear divisor. And if you think back to those first problems we did, only one of those we've done so far would have been more efficient to do this way. Okay, so now we're going to write our answer. So I've got 2x to the 5th minus 4x to the 4th minus 3x cubed minus 6x squared minus 5x minus 8. Gosh, that's a mess. Divided by x minus 3. And I'm going to say that equals, these are the coefficients. And we're always going to have 1 degree less than the original dividend. So this one starts with x to the 5th. The quotient will start with x to the 4th. So that's 2x to the 4th plus 2x cubed plus 3x squared plus 3x plus 4 plus r of x, which is also 4, over the original divisor, x minus 3. Now, if I had used long division, that would have taken about 5 times as long. Probably.
Can you go back over just one more time how you figured out that was the remainder? Because I didn't hear that.
Sure.
Making sure I know.
So
Besides the last one, obviously, but it's not a remainder.
the table is always going to follow this pattern. So everything but the last number will be the coefficients of the quotient.
Okay.
And then the last number will always be the remainder. If it's 0, that means there's no remainder.
Okay. Got
So
it.
any non-zero value here indicates that that value is the remainder. Good question, Clay. Okay.
I'm so confused on how you got the coefficient. Like, I've seen that you multiplied by that, but do you just, I see that it's 6, 6, 9, 9, 12. Like, how did you do that?
Okay, so starting with the first number, you just bring it down.
All right.
Then I'll multiply by my special number diagonally. So 2 times 3 is 6. So I write a 6 here. Then I'll sum downwards. -4 plus 6 is 2. And I'll multiply by my special number again. So after the first term, you multiply by the special number and write that diagonally, and then you sum downward. And that pattern just repeats till you run out of numbers.
All right.
Good question, Kate. Any other questions about this? Okay, moving on. So here, this one doesn't lend itself well to synthetic division because we have an a value here. So linear functions or linear expressions can be written as a times x plus b. If a value is other than 1, then it's not a great candidate for synthetic division.
So on our homework, if it says do synthetic division, we should have to, right? But if it
For homework, yes.
Okay.
For tests, whatever method.
Okay.
So if it prescribes a certain method on a test, just use whatever works best for you. However, for the purposes of homework, I do want you to get this practice. So there will be a couple questions that say, use the synthetic division, and that's the work I want to see attached. So here's an example where they want to force us to use it in a case where it's maybe not the best choice, but we'll play along. So what you'll do is you'll rewrite the problem. Where the a is factored out. So this is our original problem. I need to factor the a value out of that denominator. See, if I distribute the 4, I'm back to here. So I factored that a value out. And now I can move that 4 up into the numerator by dividing each of these coefficients by 4. See why this wasn't the best choice? Look at all those scary fractions.
Yeah, so basically if you did it that way, it's just going to come up to fractions.
Indeed. Yeah, that's the challenge is you got fractions. Now, you know, I've had a lot of practice manipulating fractions. You guys maybe less so. And for some people, there's a real aversion. You know, if you see a problem with fractions, you just throw your hands up and say, the heck with this. Of course, that's no longer an option for you. You must master fractions. And now we're ready to use our synthetic division algorithm. So -1/4 means our special number is +1/4. And then our numbers across here, 8/4 is just 2. 38/4 would reduce, let's see, that would become 19/2, 5/4, 3/4, and 3/4. So starting with 8/4, which reduced to 2, I wrote a list of our coefficients of our dividend, reducing them as I went here. So bring down the first number 2. 2 times 1/4 is 1/2. And then I sum downwards, and so that's 20/2, which is just 10. Stop me if you're not sure where something came from. 10 times 1/4 is 10/4. Yep. Make sure that's right. Yep. Let me just double check something real quick. Because I do not want to make a boo-boo. +1 so it's saying that this is plus. Yeah, okay. No problem. We'll just go back and make these pluses. And the only thing that changes is this is negative. Okay, so that was a boo-boo on my part. Let me fix these. Okay, so this should have been negative because that was plus. Okay, so 2 times negative 1/4 instead is going to be negative 1/2. 19 plus a negative 1 is 18/2, which reduces to 9. 9 times negative 1/4 is negative 9/4, which 5 plus negative 9 is 4/4, which again reduces to just 1. So we'll just write it as 1 here. 1 times negative 1/4. So that's 2/4 or 1/2. 1/2 times negative 1/4. That'd be negative 1/8. Again, let me check my work here because I can't remember if that's negative, positive 1/4. Oh, yeah. So that's negative 1. Dirt. We'll get it right. There we go. So again, meticulousness, attention to detail, going back and checking your work as you go. I know it's kind of tedious to watch, but it's an important lesson for you because it's the only way you're going to get these problems right. You're not going to just steamroll through them and get everything right immediately as you go. You're going to have to constantly go back through and check yourself. So 1 times negative 1/4 is this, and 1/2. So here I've got the coefficients of my quotient polynomial, and there I have the remainder. So the answer is going to be for this problem. And remember, we started with the 4th power of x. So this time our first term is going to be to the 3rd power. Like so. So that's a perfectly good answer as far as I'm concerned, but sometimes your book likes to simplify this like so. So complex fractions are technically not fully simplified. So that's when you have a fraction within a fraction, like you see here. Anything that is a denominator in the numerator's fraction, I can just multiply the denominator by, like so, and get 2x cubed plus 9x squared minus x plus 1 over 2x plus 1/2. So that's probably, if you looked in the back of your book for one of these or something, you're probably going to see it in this mode. And it's important for you to know, I would give this full credit on a homework. But comparing answers, you may see something like that. Questions about any of this? Okay, so we've done long division. We've done synthetic division. Now it's time to talk about the remainder theorem. So if I divide by x minus c, the remainder is also the function's value at c. In other words, synthetic division can be a shortcut for evaluating a polynomial. Again, best demonstrated via an example. So if f of x is divided by x minus c, the remainder is the function's value at c. So if I divide by x minus c, whatever's in that rightmost column in synthetic division is the function's value at c. This lesson always runs a little long. Just a lot to cover. So divided by x minus c, the remainder is the function's value at c. And so suppose 800 units of beachfront property have tenants paying $600 per week. $600 per week for a beachfront property. How old do you think this question is? Pretty old. It's about 5 times that amount now. Research indicates that for each $10 decrease in rent, 15 more units would be rented, blah, blah, blah. Here's the function that describes that situation. Use the remainder theorem to find the revenue from the properties if the managers decrease the rent by $50. So each X is a $10 decrease. So if they decrease by 50, so X equals 5. So we need to plug in X equals 5. Now I could do negative 150 times 5 squared and so on. I could just plug it in other words. But we're going to use our little shortcut here, and we're going to divide that original function by X minus 5. And then the last column in our synthetic division will be R of 5. So that's going to be special number 5, and then negative 150, 1,000, and 480,000. So I bring down my first number, negative 150, multiply by 5, I think that's negative 750. Yep. And then I've got 250 times 5, that's 1250, I believe. And 481,250 is our answer. So we know it's some quotient, which is this, and then plus this value is also the function's value at 5. So it's unnecessary to even write any of that. I just want you to know that relationship. This value is the function's value where X equals 5. Questions about that? It's just a quick way. Do you see how much faster that was than plugging in X? So it's just an efficient method to do it mentally if for whatever reason you don't have a calculator handy. Still faster to do it by calculator, but this is the fastest by hand method. Okay. It just, yeah, that's right. So the factor theorem says X minus C is a factor of f of X if and only if C is a 0, which makes sense when you think about it. So if I divide two polynomials, the only way the divisor is a factor of the dividend is if the remainder is 0. So the remainder must be 0 for the divisor to be a factor of the dividend. That's basically what this says. If I divide two polynomials and I get 0 as their remainder, then that divisor is a factor of that dividend. Let's think about it in arithmetic terms. What is 49 divided by 7? So I say 7 is a factor of 49. What is 43 divided by 7? And remainder? 1. So because it has a non-zero remainder, 7 is not a factor of 43. Do you see what I mean? So the same is true for polynomials. It's just a little more complicated. If I've got some original polynomial, if I divide it by some other polynomial, and the remainder is 0, then the second is a factor of the first. In the same way, 49 and 7, dividing evenly may ensure that 7 was a factor of 49. Again, maybe best demonstrated with an example. So use the factor theorem to determine if these are factors of this polynomial. So we're going to test this one first. So I'll do that one in red. 5 is our special number here because it's X minus 5. The coefficients are 1, -18, 60, and 25. Bring down the 1, 5, -13. -13 times 5 is -50, -65. And then -5, -25, and 0. So what do we say? Factor, yes or no? Indeed. Now let's try +5. And we'll do that one in blue. So it'll be the same. We can reuse our work here. Of course, all the numbers will be a little different. Up to this point, though, the only thing different is I wrote -5 in this box because we're testing x plus 5. So that's a -5. 1 minus 5, -23. -23 times -5 is positive 115. So that's 175. Do I really need to go much further here? Clearly not going to be 0, but we'll go ahead and work it out. So 175 times -5, so that's -500, -850, -875, I believe. And then, so that's not 0, and we get a big old fat no for that one. Any questions at all about anything? All right, appreciate you guys. I know the lesson was long today, but I'd like for you, if possible, to complete page 115, 4, 10, 20, 32, 44, 61 by Wednesday. This will be due Wednesday.